Hello everyone. Today we'll see how to add a new library or new package in MATLAB. So for example, we'll see about how to add YALMIP package. YALMIP is a kind of software used for optimization purpose. It contains some solvers like Mosaic, ZUMI, Kurobi, all these solvers you can use to solve the optimization problem. So to install the YALMIP, we first need to go to this YALMIP GitHub page. You can directly search YALMIP download. We'll reach to this page. So we can download the latest release here. I have downloaded it already, and you can install it in wherever you want. So after installing it, uh, execute the YALMIP and extract it. So now we'll open the MATLAB. So in MATLAB, after installing it, we'll need to set the path so that MATLAB can have access of this YALMIP. So in set path, this in home toolbox, there is a set path. We can go to add with subfolder. So when you have installed it, wherever you installed it, go to that folder and install it in MATLAB file toolbox manager, toolboxes, and YALMIP. So I'll select this and select folder. I already selected it, so I'm not selecting it, but this is the way to add. There is also a command line for this add path. If you know the address of this YALMIP, you can directly add path with the command line, but yeah, GUI is better. Okay, so now this YALMIP is added. Let us see few example, some example of this. So let us create a variable x. Let me increase the size. Good. So let us create some variable x with stp var. Let us keep it one. We can directly write one also, a single variable. So now our objective function will be, let's say, x minus 2 square. Yeah, this is just a simple polynomial. We know that the minima will be at around x is equal to 2. So we'll be solving the minimization problems of this objective and verify the answer. Okay, now we can also set some constraints. So you can directly write constraint is equals to, uh, it is in array format. So suppose I want to give x is less than or equal to, let's say 3. We'll first do with 3, then we'll see other things. So you can add with comma, x is greater than, let's say, minus 3. So these are the constraints added. Now there is something called options. So it is the basically setting the STP settings, like what solvers we need to use, and if we want to print the data like while executing the program, seeing everything, we can do that also. Suppose I'm choosing Mosaic. Uh, there is a separate video for this Mosaic, how to get the license and how to install the Mosaic. Once you have installed it, this will work very fine. Okay, so I'm also setting verbose. This is basically to print the informations which we get. So sol is equals to optimize. Optimize function is used with the YALMIP. So this takes the constraints objective function. By default, this objective function is will be minimized. If you want to maximize it, then we have to put minus here. Okay, minus objective. Yeah. And then options. Now we also need to check if the solver has solved the problem or not. So if this current value is 0, it means that the feasible solution has come. If there is any other number, then you can directly check via a function which is called YALMIP error. Okay, so this will print what actually this number means. So we'll see, this will print something. And if we want the solution, x solution, this will be value of x. Yeah. So now let us run this. So this YALMIP error printed successfully solved, and that solution we got true. So you can see the optimization has worked successfully. Suppose I take x is less than 1 as a constraint. So the value will be something like at x is equals to 1 will be minimum point. So let us see what the solution comes. Yeah, the solution is x equals to 1. If you also want to see the objective value, what is the objective value at that point, then you can also see the value of OBG. So this will print the value of the objective function at that optimal point. Let's not save it. Yeah, the value is 1 here. So if I increase this to, let's say, 3, so we'll get usually, it should be 0, but yeah, because it is a numerical calculation optimization, so it will be close to 0. It is close to 0, which is definitely equal to 0. So we'll see some more problems regarding optimization and how to solve this using YALMIP. Thank you.